All right, we're back. This is Math 200. We're looking at Chapter 3. This is on graphing. And so let's begin. So page 1 is just a bunch of information. Rectangular coordinate system. We have ordered pairs. They're called coordinates also. We have the x-axis, the y-axis, the origin, and the quadrants. We graph points by getting coordinates x and y. That's how many right or left, and then how many up or down. And so this is quadrant 1. This is when x and y are both positive. Quadrant 2 is when x is negative and y is positive. Quadrant 3, x and y are both negative. And quadrant 4, x is positive but y is negative. All right, so when we look at points to graph, this is the x-axis. This is the y-axis. This is the origin, 0, 0. And so if I want to graph 5, 3, that's 5 to the right, 1, 2, 3, 4, 5 to the right, and 1, 2, 3 up, and that's the point in space. That's 5, 3. So 5 to the right and 3 up from the origin. All right. Let's say I want to graph 0, 5. Well, that's none to the right or left, 0 right or left, and then up 1, 2, 3, 4, 5. So that lands right on the y-axis. Anytime there's a 0 first in the x, it has to end up on the y-axis. All right, then let's do -4, 2. That's 1, 2, 3, 4 clicks to the left, and then 2 up, 1, 2 up. So that's -4, 2. And then let's graph -6, 0. So that's 1, 2, 3, 4, 5, 6 to the left from the origin because of the -6. And then 0 up or down. So that's exactly on the x-axis. And let's see, I got one more point, 2, -4. So positive 2 is 2 to the right, and 1, 2, 3, 4, -4. And there we go. So that's the basics. They want us to graph points A, B, C, D, and E. So let's graph those ordered pairs. We got 4, 2, 1, 2, 3, 4, 2. That's right there. That's point A. Point B is -3, -2. So 1, 2, 3, 1, 2, -3, and then -2. It's always from the origin. C is 2, -3. So 2 to the right, and then 3 down. D is 0, 4. So 0 right or left, and then 1, 2, 3, 4 up. And then E is 5, 0. So 5 to the right, and then none up or down. So be careful on the ones with 0, 0, 4, and 5, 0. Throughout my career, those are usually where people make mistakes with graphing points. All right, so now determine, is this point on the line? This is called a linear equation because when we do the graph, if we solve it for y and we do the graph, we get a line. That means there's an infinite amount of points, x and y, that will fit on this line. So this may be one of the solutions. That's why it's a solution and not the solution. All right, so we just put in 3 for x and -2 for y. And then we see if that shakes out to be true. So I put a little question mark over the equal sign. That's not an actual mathematical symbol. It's just, I want you to know, we don't know if it's equal to or not until we do this calculation. So please excuse my dear Aunt Sally, we multiply first. So 5 times -2 is -10, 2 times 3 is 6. Now it's still, does that equal -4? And the answer is, it does. Yay! So that means 3, -2 is a point that does lie on this line. If we were to graph this line, one of the points on the line would be 3, -2. All right, so that's yes. 3, -2 is a solution. Okay, let's take a look at 3x minus y equals 5, and they want me to test -1, 6, see if that's on the line. So 3 times -1 minus, just put a 6 in there, does that equal 5? So we got -3 minus 6, that's -9, that does not equal 5. So that is not a solution. So what that means is that is a point in space, but it doesn't lie on this line. All right. Okay, so we're on the bottom of page 3 in the note packet. Let's graph by picking points, by building a table. So this is not very efficient. This is a way to graph a line, but it's not the quickest way, and nor is it the easiest way. But I want to show you, just so you know, there's more than one way to graph a line. What we are going to do is pick 3 values for x. And what I tell my students is you can pick any values you want. You could pick x equals 100. You could pick x equals -10,000. Whatever you want, you could pick for x. But here's the rub. We need it to kind of stay small. We want to think small because we're trying to graph it on this tiny little coordinate plane that only goes up to 5 and over to -5 and up to 5 and down to -5. So it's not big. It isn't big scale. So we want to think small, not big. So like what's small? Well, x, let's pick 0. So we're just picking 0 because it's easy to work with. 0 times anything is 0. So I pop in 0 where the x was. And now we go back to the first chapter, or the second chapter, chapter 2, solving equations. So look, 0 times anything is 0, so I got -y equals -4. I'm not done because I want 1y equals. I divide by -1, or multiply by 1. That's 4. So 0, 4, that's one of my coordinates. That is a point on the line. Let's pick another one. How about -1? That's small. -1, 2 times -1 minus y is equal to -4. So I got -2 minus y is equal to -4. So now I want to solve that equation. So again, we're morphing back to chapter 2 where you're solving equations with a single variable. +2, -y is equal to -2, divide by -1. Y is equal to 2. 2 down. Now really, 2 points determine a line. I could be done, but usually in the books, it'll tell you I do 3 points, because then the third one is like a test point, meaning that if I put in a third point, I should get them all in a line. If I get a triangle, then one of the 3 of them is wrong. So by finding a third point, I'm confirming my straight line. So I'm going to put -2 in there. Now again, if you picked 1, that would be fine. If you picked 2, that would be fine. It's just then you're going to end up with a big positive number. You're going to have to add lines to it, kind of. So we got that. So this one is going to keep it small. -4 minus y is equal to -4. I add 4 to isolate the variable. So I got -y is equal to 0. Divide by -1, so y is equal to 0. So I just randomly, well, not randomly exactly, I picked smaller values to try to keep it small because I'm going to try to graph it on this 5 by 5 coordinate plane. But really, these I chose, that's the independent variable. These we figured out, that's the dependent variable, to get these coordinates. And now when you graph these coordinates, I got 0 to the right or left, 1, 2, 3, 4 up, 1, 2, 3, 4. I put a dot there. I got -1, that's 1 to the left, 2 up, that's right there. I got -2 to the left, 0 up, that's right there. And see, they're all in a row. And make sure you put arrows on the line. These lines go on infinitely on that, in that direction, meaning that no matter what, I could go to x equals 100, and that would be way, way, way up there. I could go to x equals -50, and that would be way, way, way down here. And so those arrows on the end signify that the line is infinite in both of those directions. All right? Let's look at a couple more here. Alrighty. So now we're looking at number 2 is y equals 3/4 x plus 3. They want me to graph that. And so again, we're going to do an xy table. I'm going to pick things. I'm going to pick 0. That's a good choice because look, I popped 0 in there and whammo. It's gone. No fractions. So it's just y equals 3. Also, if you get a fractional answer, it's not the end of the world. I specifically picked things that were divisible by 4. So I picked like 3/4. I put in -4. So I pop in a -4 plus 3. Well, what does that do? That's going to cancel the 4. So I'm going to get -12/4 plus 3, but that's -3 plus 3. Oh, which happens to be 0. All right, I picked +4. What happens if I pick a +4? Well, what that does is that means I'm not working fractions. But even if I would have picked 2 and it turned out to be a fraction, just make it into a decimal and put your decimal down and then just kind of guesstimate where the decimal lands and you're fine. It doesn't matter if you're doing it this way. So look, this, instead of 12/4 like I did there, I could have just canceled the 4s and said, look, that's 3 plus 3. That's 6. So see, this is one of those things I was talking about. So I got 0, 3, 1, 2, 3 right there. I got -4, 0, 1, 2, 3, 4, 0. But now I got 4, 6. Well, that's 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. It ends with 5, but I'll have to just kind of squeak in another, make a 6th thing, and so the dot's actually a little above, you know, it's a little off the chart on what we had to graph there. And then put in your straight line, and remember the arrows on the end. It's infinitely going forever in both of those directions. All right. So let's take a look at intercepts. They want me to graph it with intercepts. So what that's going to look like here is we've got 4 is equal to x minus 3y. And when they want you to find the x and y intercepts, what they want you to do is you pick 0 for x, and that'll give you the y-intercept, but then you also pick 0 for y, and that'll give you the x-intercept. All right, and so when we're looking at that, 0 for x, that's not going to be pretty. That's going to be 4 is equal to 0 minus 3y. Negative 3y is equal to 4. Divide by -3, divide by -3. And so here we are. Look, I've got -1.3 repeating forever. We'll just round it to tenths and leave it -1.3. All right? Put in 0 for y, that'll work out much nicer. 4 equals x minus 3 times 0 for y. That's going to be much easier because that just zeroes out and you get x is equal to 4. So that was like solved itself. And now we just graph just those 2 points. So we're kind of living on the edge here. We're only using 2 points to graph a line, so there's no confirmation that we're doing it right here. So 0 right or left, and then 1.3 down. So just, this is what I mean by guess. If there's 1, there's 2, about 1/3 of the way. And then 4, 0, 1, 2, 3, 4, 0, and then just connect the dots. And put the arrows on the line. All right? Okay, and then here, last on this page, the bottom of page 4, we got x equals 3. Those are easy, quick ones to graph. When it's x equals a number, it's a vertical line through that number. When it's y equals a number, it's a horizontal line through that number. So x equals 3 is just a vertical line through 1, 2, 3. Count on the x values out to 3, and then just draw in a vertical line. And that's it. So when it's just x equals, vertical line. When it's just y equals, horizontal line. All right. Vertical lines have undefined slopes. Horizontal lines have slopes of 0. And we'll revisit that. In fact, there it is on the top of 5. That's the other scenario. Y equals 3. And they want me to graph that. But you don't have to do an XY chart. It's just you go up to 1, 2, 3 and draw a horizontal line. That's it. If you wanted an XY chart, no matter what you pick for X, Y is always 3. So you just put in 3's no matter what right there. And no matter what X is, if X is 1 or 2 or -1 or -2, look, 1, 3 right there. 2, 3 right there. -1, 3 right there. -2, 3 right there. You don't really need an XY chart. It's kind of silly to do an XY chart for X equals or Y equals. That's just kind of a memorized thing. All right. So the next video we do will be 3.2, slope of a line.